Hi folks, we're going to do another projectile problem, and this is going to be regarding football on the planet Zorg. Here goes. In the future, a group of astronauts will introduce the game of football to the inhabitants of the planet Zorg. During one of these rousing games, the ball is kicked off at an angle of 35 degrees above the horizontal with a velocity of 38 meters per second, and it lands 60 meters away. What is the acceleration of gravity on Zorg? Okay, now, whenever an object is kicked off at an angle, what's the first thing we do? Yep, we find those vertical and horizontal components. So 35 degrees above the horizontal, 28 meters per second. I want to find the original vertical velocity. My goodness, that jumped on me, didn't it? I want to find the original vertical velocity, and I want to find the horizontal velocity. So horizontal velocity, this is going to be my adjacent side. So this is going to be my hypotenuse times the cosine of theta, or 28 meters per second, times the cosine of 35. And when I do the math on that, I ended up with 22.9 meters per second is my horizontal velocity. The vertical side is the opposite, so this is going to be the sine of theta times my hypotenuse, and that is going to be the sine of 35 degrees times 28 meters per second, and that is going to end up being 16.1 meters per second is my original vertical velocity. Next, I need to draw a little picture and see what's going on. So here is football on Zorg. It's shot off with an original vertical velocity of 16.1 meters per second. Its horizontal velocity is 22.9 meters per second. It goes 60 meters. That is my horizontal displacement. X is 60 meters. And I want to know what is the acceleration of gravity. To do this, as always in projectile problems, I have to have two columns, a horizontal side and a vertical side. On my horizontal side, I know 22.9 meters per second. I know it's going to travel 60 meters. And yay, hey, I can find time, because on the horizontal side, the only equation I can use is the constant velocity equation, x over t. So time in the air is going to be x divided by velocity, 60 meters, divided by 22.9 meters per second. I'm going to end up with a time of flight of 2.62 seconds. When it hits the ground, it hits the ground, so that's going to be the same time on the other side, 2.62 seconds. Now, the original vertical velocity on Zorg was 16.1 meters per second. That is when it was shot up. When it came down and hit the ground, it was going final vertical velocity, negative 16.1 meters per second, and I'm looking for gravity. So what am I going to use for gravity? Well, I'm going to use that sweet little poopsie equation I really like, VF equals VO plus a t, and I'm solving for gravity. So acceleration of gravity will be final velocity minus original, divide the whole thing by time. Final velocity is a negative 16.1 meters per second, minus my original vertical, 16.1 meters per second, and all of this happens in 2.62 seconds. When I do this, what do I get for the acceleration of gravity on Zorg? I got a negative 12.3 meters per second squared. What does the negative mean? Well, the negative sign tells me that gravity is pulling downward. There you go. Next time you're on Zorg, you know the acceleration of gravity. See you later. Bye-bye.